psi of x comma y comma z comma t is equal to a e power I 4x plus 3y plus 5z minus 10 pi t, where a is a constant, the unit vector representing the direction of the propagation of this matter wave is. So in this question they have given a wave function and they have asked us to find the unit vector representing the direction of propagation of the wave. So first we will write the given wave function. Psi of x comma y comma z comma t is equal to a e power I 4x plus 3y plus 5z minus 10 pi t. We know that the general form of the wave function is psi of r comma t is equal to a e power I k vector dot r vector minus omega t, right? So let it be 1. Now we can write the given wave function in terms of the general form. So we will be getting psi of x comma y comma z comma t is equal to a e power I 4 I cap plus 3 j cap plus 5 k cap dot x I cap plus y j cap plus z k cap, right, minus 10 pi t. Let it be equation 2. Now by comparing 1 and 2 we can write k vector is equal to 4 I cap plus 3 j cap plus 5 k cap, right? Now we have to find what is the unit vector of k vector. So k cap is equal to k vector divided by mod of k. So first we will write the k vector 4i plus 3j plus 5k cap divided by square root of modulus, that is 16 plus 9 plus 25. So by simplifying it we will be getting 4i cap plus 3j cap plus 5k cap divided by 5 root 2. So therefore answer is option A. A function f of t is defined only for t greater than or equal to 0. The Laplace transform of f of t is integral 0 to infinity e power minus st f of t dt, whereas the Fourier transform of f of t is integral 0 to infinity f of t e power minus I omega t dt. The correct statements is are: A. The variable s is always real. B. The variable s can be complex. C. Fourier and Laplace transformation can never be connected. Option D. Laplace and Fourier transformation can be made connected. So in the question they have given a function f of t and they have said that the function can be defined only for a t value of greater than or equal to 0. So they have given the Laplace transformation of the function and Fourier transformation of the function, and they have asked us to find which among the four options is the correct one. So first we will take a function e power minus at and try to find what is the relation between Laplace and Fourier transformation. The Laplace transformation of e power minus at is 1 divided by s plus a, and the Fourier transformation of e power minus at is 1 divided by I omega plus a. Now Laplace and Fourier transformation, if you see these two things, if we can write s is equal to I omega, then Laplace transformation is equal to Fourier transformation. So we can write Laplace transformation of e power minus at when s is equal to I omega is equal to Fourier transformation of e power minus at. Now in the similar way, if you see the given Laplace and Fourier transformation, here also the Laplace transformation of the function in terms of s at s is equal to I omega goes to I omega is equal to Fourier transformation in terms of omega. So we can say that Laplace and Fourier transformation can be connected. They both are related with each other. So option D is a correct one. And here the value of s is a complex one. So the variable s can be a complex one. So answer is D option and B option. P and Q are two Hermitian matrices and there exists a matrix R which diagonalizes both of them such that Rp R inverse is equal to S1 and Rq R inverse is equal to S2 where S1 and S2 are diagonal matrices. The correct statements is R. So in the question they have given a two matrix P and Q. They both are Hermitian matrix. And also there exists a matrix R such that the diagonalizing of the matrix P and Q gives a result S1 and S2. So first we will write P and Q are Hermitian matrix. And they have given R, P, R prime is equal to S1 and R, Q, R inverse is equal to S2. Okay, diagonalizing the matrix gives the result S1 and S2. S1 is nothing but eigenvalue of P and S2 is nothing but eigenvalue of Q. So we know a property of Hermitian matrix that eigenvalues of a Hermitian matrix must be a real one. Okay, so option A is a correct one. All the elements of both matrix S1 and S2 are real. Okay, now we have to check the other option. Now you can see that both the matrix P and Q are diagonalized by the same eigenvector. So if both the matrix shares the same eigenvector, then they commute. Therefore, PQ is equal to QP. So option D is a correct one. The matrix P and Q commute with each other. Now we have to check the option B and C. We know one more property of Hermitian matrix. The product of two Hermitian matrix A and B, let it be, is Hermitian if and only if they commute. AB is equal to BA. So here they have said the product of Hermitian matrix is a Hermitian only if they commute. Already we have proved that P and Q commute with each other. So their product is also going to be a Hermitian matrix. So in the question they have given the matrix PQ and QP have a complex eigenvalue. No, it will have a real eigenvalue. So this option is incorrect. Answer is option A and D. A contour integral is defined as I of n is equal to closed integral of dz divided by z minus n the whole square plus pi square, where n is a positive integer and c is the closed contour as shown in the figure, consisting of the line from minus 100 to plus 100 and the semicircle transversed in the counterclockwise sense. The value of summation n is equal to 1 to 5 in integer is. So in the question they have asked us to evaluate what is the value of I of n from 1 to 5 and they have given the value of I of n. So first we have to find what is the pole by equating the denominator to 0. Z minus the whole square plus pi square is equal to 0. So Z minus n the whole square is equal to minus pi. Taking square root on both the sides, z minus n is equal to plus or minus pi I. Therefore, z is equal to n plus or minus pi I. These are the poles. Now we have to check whether both the poles lies inside the semicircle or not. So only the pole, one pole value is n comma pi I and another one is n minus pi I. Only the pole n comma pi I lies inside the pole. N minus pi I lies outside the pole. So we have to consider only n plus pi I. So I of n is equal to 2 pi I limit z goes to n plus pi I into z minus n plus pi I into 1 divided by z minus n plus pi I into z minus n minus pi I. So these two will get cancels off, and by applying the limits 2 pi I into 1 divided by n plus pi I minus n plus pi I. So these two will get cancels off. So we will be getting equal to 2 pi I into 1 divided by 2 pi I. So it is going to be 1. So I of n value is equal to 1. So we have to find summation 1 to n is equal to 1 to 5 in. That is I1 plus I2 plus I3 plus I4 plus I5. So that is nothing but 1 plus 1 plus 1 plus 1 plus 1. That is 5. If yn of x is a solution of the differential equation y double prime minus 2xy prime plus 2ny is equal to 0, where n is an integer and the prime denotes a differentiation with respect to x, then acceptable plots of psi n of x is equal to e power minus x square divided by 2 yn of x is r. In this question, they have given a differential equation and yn of x is a solution for this equation. And they have given a wave function psi n of x is equal to e power minus x square divided by 2 into yn of x. And they have asked us to find which among this four plot is a correct plot of psi n of x as a function of x for different values of n. Here in these two plots, the n value is 0 and here the n value is 1. First we will write the given differential equation. Y double prime minus 2xy prime plus 2ny is equal to 0. Okay, this is nothing but a Hermite differential equation. And the solution yn of x is nothing but a Hermite polynomial. Hn of x, and Hn of x is given by minus 1 the whole power n e power x square d by dt dx power n e power minus x square. Right, this is the Hermite polynomial. Now we will see what is the value of Hermite polynomial for n is equal to 0 and n is equal to 1. At n is equal to 0, we will be getting h0 of x is equal to, we will substitute 0 here and here, we will be getting simply 1. At n is equal to 1, we will be getting h1 of x is equal to, we will substitute 1 everywhere, we will be getting minus 1 the whole power 1 e power x square d by dx of e power minus x square. By differentiating it, we will be getting minus 1 the whole power 1 into e power x square. If we differentiate x square, you will be getting e power minus x square into minus 2x. So by simplifying it, we will be getting simply 2x. So h1 of x is equal to 2x. We have found the value of h1 of x and h0 of x. Now we will substitute it value in the wave function. Then we will be getting, we will write the function first. Psi n of x is equal to e power minus x square divided by 2 psi n of, y yn of x. So you will be getting psi 0 of x is equal to e power minus x square divided by 2. Yn of x is nothing but here it will be y 0 of x, and for psi 1 of x it will be e power minus x square divided by 2 into psi y1 of x. So y0 of x is nothing but h0 of x, and y1 of x is nothing but h1 of x. If we substitute it, we will be getting psi 0 of x is equal to e power minus x square divided by 2, and psi 1 of x is equal to 2x e power minus x square divided by 2. Now we have found what is the value of psi 0 of x, that is for n is equal to 0 and for n is equal to 1. Now we have to find what is the value of this function as a function of x. Okay, now first we will see what happens when x is equal to 0. At x is equal to 0, psi 0 of 0 is equal to e power 0, that is equal to 1. Psi 1 of x 0 is equal to 0. At x is equal to plus or minus 1, psi 0 of plus or minus 1. Whether it is plus 1 or minus 1, this x square e power minus plus or minus 1 the whole square divided by 2. Right, it will be always positive, so we will be getting e power minus 1 by 2. Right, so we can simply write here it is e power minus 1 by 2, and psi 1 of plus or minus 1, that will be for plus 1 it will be 2 into e power minus x square divided by 1. It will be 1 divided by 2. And for psi 1 of minus 1, we will be getting minus 2 e power minus 1 by 2. We will see the options, given options, to see whether any option is correct or wrong. Now if you see option A, for all values of x, the value of psi n of x is 1. That is same value. But now what we have found is, for n is equal to 0, psi 0 of 0 value is 1, and psi 0 of plus or minus 1 value is equal to e power minus 1 by 2. So for different values of x, the wave function value is changing. So this option is incorrect. It is not the value of this given function, it's not same for all the values of x. It is different. Now we will see whether we can eliminate any of the option B, C or D. Right? For n is equal to 0, we know the function psi 0 of x is equal to e power minus x square divided by 2. E power minus x square by 2 corresponds to a give rise to a Gaussian curve. So psi 0 of x must be a Gaussian curve. If you see option B, here you are getting a Gaussian curve. So this is a correct option. Now for n is equal to 1, we get psi 1 of x is equal to 2x into e power minus x square divided by 2. Right? If you see option D, they have given a straight line. But 2x into e power minus x square by 2 cannot give a straight line, and also this is not an equation of a straight line. So this option is an incorrect one. Right? We have already said e power minus x square divided by 2 corresponds to a Gaussian curve. So it will be like this. Right? Now when x is equal to 0, what happens here? Psi 1 of 0 is equal to 0. Now if you see option C, for psi x is equal to 0, the value is 0. And here this part corresponds to a x of negative value. And this corresponds to a x of positive value. Now for x of negative value, we will be getting this particular part. And for x is equal to positive value, we will be getting this particular region. So this option is a correct one. So correct options is B and C. In this question, they have given a logic gate and they have asked us to find what is the output. So let us take the input as for this first gate as A and this is B. So this is a NOT gate. So its output is going to be A bar and B bar. So this is a OR gate. So output is going to be Y is equal to A bar plus B bar. That is nothing but A bar AB the whole bar according to De Morgan's law. So this is an output of a NAND gate. So answer is option B. In the description box, you can find the solution for GATE 2018, 19 and 20 question paper. Please share and subscribe the channel.